G'day. Today I'm just going to show you how to use DEsolve on the TI Inspire CAS calculator. Um, just going to go through a couple of different types of problems like these. Okay, so we'll just jump straight in. So if you've got dy dx is equal to x cubed plus sine x, let's show you how to do that. And the new CAS is a bit different, but I'll show you what the format that it comes out in. So menu, calculus, and then right down the bottom D is a differential equation solver, so DEsolve. And you just need to type in the equation of your differential equation. So here this is going to be, so dy dx, the way it's represented is y. And then in the pi menu, this dash, that's the derivative of that. So that means dy dx, what I've just typed in there. So that's dy dx equals, and I can't even remember what it is, it doesn't really matter, it's x cubed plus sine x, right? So x cubed cubed plus sine x. So there's my dE. Okay, so dy dx is equal to x cubed plus sine x. You have to tell the calculator what the independent variable and what the dependent variable is. Okay, so here the independent variable is x and the dependent variable is y. And so basically it's dy dx, the top line, the y is the dependent variable, the bottom line is the independent variable, and it's going to be x and y independent dependent, 90% of the time, unless you've got dy dt or, d theta dt, something like that. But most of the time it's like that. Now, if you haven't got any conditions, then you just leave those blank. So you leave them as optional and you press OK. And what that does, it just puts this into the DEsolve like that. And you can see there, that's the syntax. So if you haven't got the wizard, when you press DEsolve and it just comes up with the brackets, this is what it looks like. So you still type in the DE, equation, comma, independent variable, comma, dependent variable. So like I said, 90% of the time, comma x, comma y, and it gives you the solution to that. So the solution to that d is y equals negative cos x plus x to the power 4 over 4 plus c1. So that c1 is your constant of integration. Okay. Now, what about if you're given? And so in our second example, you've got an initial condition of y2 is equal to 1. So y is equal to 1 when x is equal to 2. So same DE, let's do that again. Maybe I'll just do it the old school way, right? No, I'll show you. I'll show you how it works. So menu, calculus, down the bottom, D for differential equation. And then again, we're going to y. Pi menu is where you find the dash for derivative. Y derivative is equal to, I've already forgotten, it's x cubed. It really doesn't matter. But it's good for you to be able to see. I'm just typing it in just to save a bit of time on my laptop. So plus sine x is what we were doing there. Yep, sine x. Independent variable x, dependent variable y, and the condition is where you put a condition in here. And so for this question, y2 is equal to 1, and that's exactly how we write that. So y2 equals 1. And the questions that you get in the exam or whatever will say, and y is equal to 1 when x is equal to 2, or something like that. But the calculator wants it written how I've written it there. Press OK. And you see the syntax there. What it's done from the above one, it's written space and then the condition. You list the condition there. If there was another condition, you'd write and again. So if you haven't got the wizard, the thing that does it for you, that's the syntax written there, so you can see that done. So, and then the calculator do it for you. And you see there's no C1 anymore because we had the initial condition. The calculator figured out what the value is C for you. Okay, hope that makes sense. Let's go on to the third one. The third one, the second derivative is equal to x squared, and we have two conditions. So here, menu, calculus, DEsolve. Here, instead of doing a 1 dash, we're doing 2 dashes. Okay, so the second derivative will have 2 dashes. Oops, not comma. I missed it. The second derivative is equal to x squared. Again, independent variable. Oops, I missed it. X, dependent variable y. If we don't put any conditions in, look what we get. So second derivative, that's the syntax you can see there. And then you get two integration constants there, and that's because we've integrated twice, as we would expect. Okay, so normally you would have been given a condition so that you can fully solve this thing. So let's have a look at what that looks like. So menu, calculus, DEsolve, I'm just going to go quickly on my calculator, save a bit of time. Second derivative, what do we say? X squared, I think it was. Independent variable X, dependent variable Y. Now, if we put a condition here, we could say Y naught is equal to 2. Oh, I better do it. We said here, what do we say here? Y0 is equal to 2. And the derivative of y when x equals 1 is equal to 5. So y dashed 1 equals 5. And so we can put our second one in here. Y dashed 1 equals 5. And so there I've put all my conditions in. And you'll see how the calculator does it. Again, DEsolve, you write down what the DE is. Then you say if there's any conditions, you go and. Then you write down a condition and then space and again, and then write down your second condition, comma x, comma y, and you'll see that it solves for that C4 and the C5 above. It gives you that. You could also, you don't need to have, the y and the y dash. You could have two y's or two dashes, whatever, and that'll give you a slightly different answer because, so you just put in whatever conditions you have, and the DEsolve will do the rest of the work for you. Last type of DE that you can solve is when you've got dy dx is equal to a function of y. Okay, so let's just quickly do that. But by now, you'll understand what's going on. Menu, calculus, DEsolve, and that's y dash, so derivative of y is equal to, what was it? 2 plus 3y. So 2 plus 3y. Again, independent variable is still x and the dependent variable is still y. So nothing changes there because it's still dy dx equals. The independent variable is always the variable on the bottom line of the derivative and vice versa. Okay, so if I, again, don't put any initial conditions in, that's how it looks, as you'd expect, and you get like an e to the power something, as you'd expect from a function of y. And then again, you can just put in a initial condition in there, and maybe I'll just do it by writing and y naught equals 10. So I'm just going to do that, and after the d, I go and y naught equals 10. And then it gets rid of the constant, and you end up with a definite solution to that, a unique solution to that differential equation. So I hope that makes sense. That's how you use DEsolve.